Here we have an example of how to multiply a binomial by a trinomial. So here's a binomial. We have two monomials added or subtracted together. Here we have three monomials added or subtracted together. And I mentioned in another video we multiplied two binomials together that the FOIL method only works in that scenario. And I'm going to go ahead and explain why the FOIL method is not going to work here. If we multiply the first terms, the outer terms, the inner terms, and the last terms, you're not multiplying anything by this negative 2x. So the FOIL method technically does not work. So I'm going to show you one way you could multiply all these together, and then I'm going to go ahead and use the box method. So one way that you could use is by taking the first method in the first polynomial, multiplying it by every single term in the second polynomial. So since it's a trinomial, we have 1, 2, 3. Then we take the second term in the binomial. We multiply that by everything in the next trinomial, 1, 2, 3. And then we're going to end up with 6 terms. So that is one way to do it. You would write it all out down here, and then you would go ahead and add your like terms. Now we're going to go ahead and look at the box method. So in the box method, I'm going to want to make a 2 by 3 grid because we have 2 monomials here and 3 monomials here. So when I do that, the grid is going to look something like this. If you want to draw it the other way so that you have 2 along the top and 3 along the side, you can. And then what I'm going to do is I'm going to take my binomial, I'm going to write each term along the side here. So that'll give me 5x minus 4. Then I'm going to take each term of my trinomial and match each with its own box. So that'll give me 3x squared minus 2x plus 1. Now what I'm going to do is I'm going to multiply. This is just like a Punnett square. So the number that goes in here is going to be the product of the number above and to the left. So that means we're going to be multiplying. So 5x times 3x squared is going to give me 15x to the third. Negative 4 times 3x squared is going to give me negative 12x squared. Negative 2x times 5x is going to give me negative 10x squared. It's still x squared because we're taking an x times an x. We add the exponents when we multiply, and that gets me 2. Then I have negative 4 times negative 2x. Negatives are going to cancel out when you multiply to get a positive 8x. Then here we have a 5x times 1. That gives me 5x. That's pretty easy. And same with this, negative 4 times 1, that's just going to give me a negative 4. So as I said in the other video, the really cool thing that I like about this is whenever you're using the box method, as long as your exponents are going in descending order, and we've talked about standard form in class, your like terms are going to line up diagonally. So here we have our like terms, negative 12x squared, negative 10x squared, and here we have our like terms, x and x. So the ones on the outer corners are not going to be like terms. So I'm going to go ahead and combine my like terms. I like to put little bubbles around them so I can see it a little bit easier. So once I combine them, I'm going to start off in writing my 15x cubed. I add these up, negative 12x plus 10x, or I'm sorry, it's x squared. That's going to get me negative 22x squared. 8x plus 5x is going to get me 13x. And the only thing that's left over here is a negative 4. And that's pretty much the box method summed up. And it does take a little bit of extra time, a little bit of extra work, but the really cool thing about it is it's a great way to visually organize this. Algebra is very difficult. It's not very visual. It's very hard to see. Here we just have a bunch of numbers. It's very abstract. But this method right here gives us a different way of looking at it, so it's easier to organize our information. There's less room for mistakes. So if you have any questions, go ahead and respond to the post.